Hello everybody and welcome back to Advanced Maths. Today we're going to look at the laws of indices. Indices, or powers, is just when you have something or a letter or a number multiplied by itself several times. So on screen I have the powers of a to the power 5 just means a multiplied by itself 5 times. Now we can use this to try and figure out what a to the power 0 is. And you'll realise that every time going down this list, we're dividing by a. So it multiplied by a one less time. And so we get to a to the power 1 is equal to a. And we divide by a again. And we get a to the power 0 is a divided by a, which is 1. Because a divided by a will be 1. And we've stumbled across our first rule. So rule 1, anything to the power 0 makes 1. Any number to the power 0 or any letter to the power 0 will be 1, and you can see some examples on screen for you to see. Now, we're going to divide by a one more time. 1 divided by a will give us a to the power minus 1, which is 1 divided by a. And then we divide by a one more time, and we get 1 over a squared. And so that's a to the power minus 2. And this tells us what a negative power would give us. So negative powers become fractions. So, for example, if we had 5 to the power minus 3, that would be the same as 1 over 5 to the power 3. Do you see what's happened here? The powers become positive, but it's just become 1 over. And we can work that out. 1 over 5 to the power 3 is 1 over 125, because 5 cubed is 125. Let me show you some more examples here. So 8 to the power minus 1 just means 1 over 8 to the power 1. X to the power minus 2 will be 1 over x squared. 5 to the power minus 3, we've done that one. And m to the power minus 23 will be 1 over m to the power 23. You should see the pattern there. The negative just means it's 1 over. Okay. Now, we're going to look at multiplying powers now. So what do you think b to the power 5 times b to the power 3 is? Well, let's write it out in full. B to the power 5, we're going to write that as b times by itself 5 times. And b to the power 3 will be b times by itself 3 times. So how many b's do we have? Well, count them up. We have 8 b's multiplied together. That's b to the power 8. Do you see the pattern? B to the power 5 times b to the power 3 makes b to the power 8. We are adding the powers. And so if you've got powers multiplied together, that will be adding powers. Look at some examples here. X to the power 5 times x to the power 4. You add the powers, that's x to the power 9. 7 to the power 10 times 7 to the power 4 will be 7 to the power 14. Notice that the number at the bottom stays the same. So the 7 and 7 stays the same there. It wouldn't work if those numbers on the bottom were different. Now, dividing powers is quite similar. C to the power 7 divided by c to the power 3. Let's write that out as c times by itself 7 times and c times by itself 3 times. And some of these will cancel out. So a c and a c will cancel, another c and c will cancel, and a c and c will cancel. What are we left with? 4 c's, c to the power 4. And the rule here is we are subtracting the powers. 7 minus 3 gives us c to the power 4. Rule 4. Dividing indices is the same as subtracting the powers. And let's see some examples here. So 12 to the power 6 divided by 12 to the power 4. You subtract the powers. 6 minus 4 gives us 12 to the power 2. And it will be the same if it was written as a fraction, because fractions in algebra mean the same as divide. So just be aware that it could be a divide symbol or it could be a fraction symbol, and it works the same way. Powers of powers. Okay, so here we have e squared to the power 3. Let's write that out. That is e squared times by itself 3 times. But e squared is just e times e. So we can write it out like this. How many e's are there? There are 6 e's. And so we get e to the power 2 to the power 3 is e to the power 6. The pattern here is we are multiplying the powers. 2 times 3 will give you 6. And so the rule number 5 is powers raised to more powers just multiplies the powers. Some examples there for you to see. Take a moment to reflect on those. Do you see the pattern? Okay. Now finally we have fractional powers. These are a bit messy. So you just have to see where the numbers go here. X to the power a over b. This is x to the power a fraction a over b. And that's the same as the bth root of x to the power a. Look at that again. X to the power a over b is the same as the bth root of x to the power a. And so if you have a rule 6 for fractional powers, the denominator of the power is the root and the numerator is the power. Got some examples over here. Let's look at this step by step. 9 to the power 1/2 will be the square root of 9 to the power 1. The square root of 9 will be 3. And to the power 1, 3 to the power 1 is just itself. D to the power 4/3 will be the cube root of d to the power 4. Notice how you're rooting it by the denominator and powering it by the numerator. And finally 100 to the power 3 over 2. You root it by 2 and power it by 3. The square root of 100 will be 10, and 10 to the power 3 will be 1000. And so you can work these out step by step. It just depends on you seeing the pattern of fractional powers. Let's look at some examples now. So example 1, we've got 2x squared plus 56.8 to the power 0. That looks complicated until you realise it's a power of 0, and powers of 0 are always 1. And so the final answer is 1. Next one, x squared times 3x to the power 4 plus 5x. Well, we're going to expand the brackets. X to the power 5 times 3x to the power 4 will be 3x to the power 9. Remember, you multiply. When you're multiplying powers, you add the powers. And then x to the power 5 times 5x will be 5x to the power 6. Notice that the x here is x to the power 1, and x to the power 5 times x to the power 1 will give you x to the power 6. Next one, r squared divided by r to the power 12 divided by r to the power 20. This is dividing powers, so we subtract, and we get r to the power minus 8. 12 minus 20 is minus 8. And we can write that as a fraction, 1 over r to the power 8. Because remember, a negative power makes it 1 over. And then finally, we've got this question here, p squared divided by the square root of p. Well, p squared will keep that the same, but the square root of p we can write as a power. Do you remember that the square root of p is p to the power 1/2? Okay, that has helped because now we can subtract the powers because we're dividing. And 2 minus 1/2 will give us 1.5 or 3 over 2. And so we're subtracting the powers and we get p to the power 3 over 2, which is the same as the square root of p cubed. And that is the final answer. That's it simplified as much as we can possibly do. Some harder examples here. So we've got things multiplied together in brackets to the power. So the first one, 4a to the power 5, b to the power 7 cubed. Well, what we do here is we cube everything in the brackets. And we get 4 cubed, b to the power 5 cubed, and b to the power 7 cubed. 4 cubed is 64. A to the power 5 cubed will be a to the power 15. Remember, we multiply the powers when we're powering powers. And b to the power 7 to the power 3 is b to the power 21. Example at the bottom, we've got 9x to the power 6, y to the power 10 to the power 1/2. And here we do 9 to the power 1/2, x to the power 6 to the power 1/2, and y to the power 10 to the power 1/2. 9 to the power 1/2 is 3, x to the power 6 to the power 1/2, you multiply the powers, 6 times 1/2 is x to the power 3, and y to the power 10 to the power 1/2 is y to the power 5. And that is the final answer. We've done. Okay, there's some practice questions for you to try here. So I'd like to pause the video and try these yourself. Let's see how well you've done. When you're ready, you can press play and you can see how well you've done. How well did you do? Did you get the answers correct? Let me know how well you did in the comments. Thank you for watching this week's video from Advanced Maths. We have plenty more videos for GCSE revision, so remember to like and subscribe so you don't miss any future videos. We also have our new website, advancedmaths.com. I'll leave the link in the description so you can find more videos and more resources. Thanks for watching and good luck in your exams.